Okay, here we are. So thanks to everyone for joining us today for the HortiQD third webinar. Today's webinar will be about plant health with trends and challenges in the era of pesticides usage reduction. So I will take just 5 minutes, let's say, just to give you some information about the webinar. We will listen to 2 interesting speeches, but there will be space and room for your questions. And if you look up in the above bar, there is a Q&A section, so you can ask your questions there. And we will collect them and we will try to answer the more of them. So right now, I'm going to show you the video presentation of HortiQD project, just to let you know something more about our project. Sorry, let's go to YouTube. Okay, so this is it. Sorry. So concerning the other information, just one thing before giving the word to our first speaker of today. You will receive a feedback form at the end of this webinar. We hope you can answer because it's completely anonymous. And if you answer to it, you will help us in developing the next events of our HortiQD project. So do not worry. And please answer if you can. So let's proceed with today's webinar. So the first speech will be by Professor Joanna Pułapska, and it's titled Plant Health, Trends and Challenges in the Era of Pesticides Usage Reduction. So Joanna is a specialist in horticultural plant diseases, development of methods and for detecting and identifying pathogens, their genetic diversity, genomics, and transcriptomics, and plant protection. So Joanna, the stage is yours whenever you want.
Thank you very much. I'm just sharing my presentation. And I hope this presentation. Yes, you can see it. And can you hear me?
Yes.
Okay. So thank you very much. So good morning, everybody. My name is Joanna Puławska. I'm working at the National Institute of Horticultural Research, Skierniewice, Poland. The institute is located in the center of Poland, near the capital of Poland, Warszawa, and I'm a head of department of the plant protection. In our department, we are dealing with different aspects of the plant protection to help our farmers, from the basic studies to more applied studies. And just to start today's my speech, I would like to underline that the plant protection is an always current topic. It has never been the situation, and I think it will never be the situation, that we will solve all the problems of the plant protection, that there will be nothing to do. Why? Just because natura horret vacuum. So it means that nature doesn't accept vacuum. All the free spaces must be filled with something. So if from the agriculture point of view, if we plant any plants on the field, for sometimes there will be some parasites, some pathogens which will eat this plant. So it is a never-ending story. There is a lot of challenges. The plant protection is quite complicated topic. There's many aspects which should be taken into consideration, and there is a lot of challenges which are related to this topic. The first challenge is the food security. The definition of the food security is the state of having reliable access to a sufficient quantity of affordable, nutritious food by all people independently on class, stage, gender, and religion. And the key of food security is plant-based food as a food for the humans, but also as a food for animals, which constitute the food for humans. According to a FAO stat from 2024, in the undernourishment in the world scale, there's 8.2%, what is translated to the number of people, 673 million of people. In the EU, this undernourishment has much lower level, like 2.5%, what it can be translated to about 11 million people. But still, 11 million people is not fed enough. This is one challenge, but another challenge is also that every year in European Union, we are wasting over 58 million tons of food, what is recalculated to 130 kilograms per capita, and it generates the losses of 132 billion euros. So this is another challenge. From one side, there are people who have not enough food, and from other side, we are wasting the food. Farmers have a really very limited ability to control all factors affecting the final production. And this is related, with the exception to agriculture, such conditions are not known to any other economic sector. One of these factors is a climate change. Here we have the map of the surface air temperature from the Copernicus program, and comparing to the average temperature between 1991 and 2020, we can see on the map on below here how it was, how the temperatures looked in the space of 45 years. So in the 1980 they were much below the average, and now they are higher and higher. So I think we should talk about the climate change as a fact, not as maybe a fact. Another facts, based on the report of the European Centre of Medium Range Weather Forecast, it was found that 2024 was the warmest year on the record, and the first year with an average temperature clearly exceeding 1.5 degrees Celsius above the pre-industrial level. And in 2023, also, it was found, based on the satellite measurements, that the Antarctic sea ice extent was 15% below average, and this is the lowest level in the history. What is also connected to the temperature and the melting of ice. But climate change is not only about high temperatures, but also various weather phenomena. Drought. Some area of Europe suffer drought. So this is very challenging, the source of water to water the plants on the fields. From the other side, floods. So this is the picture of the flood, which was 2 years ago on the south of Poland, and it was really very dramatic. Every day we could see the news about this situation in the TV. For example, there are some villages had to be, the people from some villages had to leave all the houses and move to another area just to survive. But besides this, there are smaller floods, but which are really impacting the food production. For example, there is a field of the red beetroot. And after 1 day of heavy rain, we have the situation like this. And what is the effect? The effect is that the farmer will have no money from this field. Because after when the field is under the water for a few days, the plants are not able to live anymore and produce and create the marketable crop. Another story, strong wind, very short but strong wind. And we have that it's completely destroyed the orchard of apples. So the farmer will not have the money from the crop this year, but he will not have money in the next years, any money of these trees in the next years, because he will have to remove all the trees and plant the new ones. And another story, it is the effect of 10 minutes hail. It was in the leek field, and after these 10 minutes of hail, also the farmer will have no crop, no money, because such a leek is not marketable. So from the one side, abiotic factors create the problem for the farmers, but abiotic changing in the climate also is shifting patterns in the distribution and severity of the different plant diseases and pests. Warmer temperature are changing, and changing precipitation are creating good conditions for the new and more aggressive threats to plant health. For example, from Poland, the apple production. Many years ago, and still apple scab is the very important most dangerous disease of apples. However, because of the increasing temperatures, we see that there is powdery mildew can be more and more danger for the apple production. Similar situation in the blueberries. Gray mold was the main disease and may treat for blueberries, but nowadays we see also the big problems with anthracnose caused by the fungus Coletotrichum, and this fungus is this genus of fungus Coletotrichum is very typical for the much warmer climatic areas than, for example, the center of Europe, like we are located in Poland. So this is no disease, but they are like changing the occurrence and the severity because of the weather conditions. Another challenge is intensive exchange of plant material. We have in EU, we have no borders, so people are buying and importing plants from different directions, but unfortunately, buying the trees, buying the new plants, they are also buying new pathogens. So, and we have contacts in the institute with farmers, and every year, definitely I can assure you that every year we have finding a new pathogen which was not found in Poland up to now. So, first group of the new pathogens, known pathogens in the world, but first time detected in Poland. As I mentioned, almost every year we have something new, and we are publishing it as a first report of the new disease in Poland. But there is also a second group of new pathogens, but new pathogens in the global context. And let me show one case study which we had a few years ago. We got the samples of the cucumbers from hydroponic production with the symptoms of so-called crazy root disease. It is a known disease caused by bacteria. Plants are creating a lot of very tiny roots, but these roots are not functional. So, and the diseased plants are not growing, and they have well, and they have much weaker yield. So we isolated bacteria. We isolated 12 pathogenic isolates. All of these isolates possess RI plasmid. The RI plasmid is a fragment of the circular DNA which is necessary to infect the plant. And based on the sequence analysis of the 16S rRNA gene, we classified these isolates to 3 genera: Agrobacterium, Rhizobium, and Pararhizobium. But we wanted to know what is the species, to which species they belong. So we tried to analyze based on the sequence of so-called housekeeping genes, which are the phylogenetic markers for the bacteria. But after sequencing of the few genes, we still could not identify these bacteria to any known species. It seems that all 3 groups of isolates, there are up to now unknowns in the species in the global context. So nobody found them before, and nobody described them before. So this is just an example, but actually during our work, we had such a situation many times, and up to now we described several new species of bacterial plant pathogens. So from one side we are a bit surprised, but from our side this is not something new. The majority of species of bacteria are still not discovered and not classified to any species. However, another changes. We had some samples of blueberry on the left side. You can see the blueberry shoots have the galls which look a bit like a hedgehog, and also beetroot with a specific kind of galls. We tried to find what is the causal agent of the disease, and despite many efforts together with the university in Opole in Poland, we could not find what was the reason of this disease. The good story is that it is not very often found. It is not the very serious disease, but generally for us it was surprising because we were testing these plants in many directions of many different groups of pathogens, and we could not find the real causal agent. So the trend is a good diagnostic. The new methods of the disease diagnostic, they are mostly based on the nucleic acids, and we are developing in our laboratory such a method. Some of them they are already patented. So this is definitely a trend, but the challenge, it is also a challenge because from one side, all these methods are, I would say, invasive. We have to destroy the plant tissue to make the analysis. And another challenge is that the diversity of the pathogens sometimes is so huge it is not possible to develop one universal method which could cover a group of the pathogens. So this is still challenging. Plant health, it is important or not? No, of course, it is important according to the statistics. Every year, the crop production is destroyed by pests, disease, and weeds, and this affects up to 40% of the global population, and it can be translated to the money, $220 billion annually. So this is quite a big problem. And there are several measures to keep plant healthy. The most important and mostly used for years, it's chemical sprayings, the chemical control of the pests and disease. And they have both positive and negative aspects. The positive, we are avoiding serious losses in production. We are ensuring food safety and security. We are protecting also against the content of dangerous compounds which can be produced by pathogens, for example, mycotoxin. But of course, we are aware about negative effects like some pesticides. It was found that they are harmful to human health, for example, by disrupting the functioning of the hormonal and immune system. They can increase the risk of cancer, and they can impair brain development during prenatal stage. So after these discoveries about these negative sides of the chemical compounds, the effect is that in European Union we have like a massive withdrawal of hazardous active substances. Generally, the chemical plant protection products have also another negative sides. Their residues can be found in food chains for the longer time. They influence the reduction of biodiversity. They changes the natural biological balance. And after some time of usage, several pests and pathogens develop the resistance to these active substances, and so the effect is the loss of the effectiveness. What is the pesticides used in EU? According to the newest statistics in 2023, in EU it was used over 292,000 tons of pesticides. Okay, so try to imagine this amount. Is it a lot of or not? So just to help you a bit, this amount of pesticides can be translated, for example, to 12,000 fully loaded trucks, or the weight is higher than the weight of 40 Eiffel Towers. So this is what we apply every single year to the environment. So another challenge, in the light of the chemization of agriculture, it is found that and it is clear now that the human activity, also agriculture, in the area of agriculture, has a negative impact on the biodiversity, but by encroaching on natural areas and disturbing ecosystem. What is this biodiversity? The biodiversity is the variety of the live organisms in the world, plants, animals, and not only in the world, in the particular habitat. And the high level of biodiversity is generally connected to be important and desirable. And in the context of the biodiversity study, the last research of the Queen's University in Belfast, they said that they found that there is drastic alert as global biodiversity loss. But they were studied over 70,000 of animal species, and they found that 48% of them are decreasing. They even stated that life on Earth is entering the 6th mass extinction. It sounds really dangerous. And this is the first extinction caused directly by one species, Homo sapiens. It means humans. Based on the report of Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, it is estimated that at the risk of extinction, there's about 1 million species of plants and animals. So this is quite a lot. And the question, have you noticed a decrease in biodiversity in the environment? You can think about a little. However, generally, we are anthropocentric, so we are putting the humans in the central and most important element of the world. So it can be that we are just not noticing this, what is happening in the environment. But is the loss of biodiversity important or not? The loss of biodiversity means the reduced ecosystem stability. It causes the threats to food production. It increases the risk of diseases, not only diseases of plants, but also risk for humans, new zoonotic diseases we have. It creates significant economic costs, accelerated climate change, and so on. And this is also found in the strategy of One Health, that we cannot consider the human health only separately, that everything is connected and there is a close linkage of human health, animal health, and environment. What is also challenging, and what is also the trend, that because of these discoveries that some of active substances in the plant protection products are negative to human health or very negative to environment, many of the substances were withdrawn, and there is still a list, quite long list of the next substances which can be withdrawn. And during last 20 years, the agriculture lost about 200 different active substances which could be used for the agriculture purposes. This is also another problem is that there's this reduction of maximum residue level for some pesticides, like last year acetamiprid. It was a big story, and in some cases it can even not be used anymore. And this is also connected to the awareness of the consumers, which want to eat the safe food and produce in the way which is environmental friendly, and also there are requirements of the local and generally global markets. So the effect, just one word, what is the price of the registration of the new chemical compound? In the 70s of 20th century, it was about $20 million. By the end of 20th century, in the 90s, the cost of the research and registration was calculated about $160 million, mostly because the increased cost of the toxicological studies. But nowadays, the cost of the registration of the new compound, development and registration of the new compound is calculated to about $300 million. And at present, the time from the first synthesis of the new chemical compound to introduction to the market, it takes over 12 years. So this is really huge money, huge effort. And the effect is that since a few last years, we have no any new chemical active substance which could be used to protect plants. And this is quite challenging. But what can be the solution? The trend is the integrated pest management. Is the system obligatory in the EU since 2014, and the main basis of this system is to integrate of different methods to protect plants, with the emphasis, with the priority for non-chemical methods. And actually there are several different actions, even starting from the selection of the field for the crop plantation, by using different non-chemical methods, like based on macroorganisms, which can be the predators for the natural predators for the pests, and so on. So one of these elements of integrated pest management is the agroecological practices in agriculture. This is definitely the trend. The agroecology is an approach to farming that applies ecological principles to agriculture system. This is very holistic view on the farm, not just pest and chemical, but very holistic view, looking on the different elements of the ecosystem, and it focuses on the biodiversity, soil health, nutrient recycling, reduced external inputs, and climate resilience. Another trend is the usage of microorganisms in the protection of plants. The microorganisms can inhabit in the world different environments. They can live deeply in the sea. They can live on the top of highest mountain. They are really very easily adapting to different conditions. They are able to metabolize and to produce a wide variety of compounds which allow them to survive better. And the diversity of microorganisms is generally not very well known. Up to now, it is described, for example, in case of bacteria, it is described a bit over 50,000 of different species, but it is estimated that we have on the Earth approximately 1 trillion of them. So this is the diversity is really huge. And microorganisms are now, this is a trend. There are new products, bioproducts are appearing on the market, and they are used to construct the so-called bioproducts, so products based on microorganisms for different purposes. The positive things of these bioproducts is that they They don't stay long in the trophic chains, the increasing biodiversity, they support for natural biological balance, they generally can reduce pathogen pest pressure, and they do not cause pathogen pest resistance. So this is very good feature. Another trend is usage of the natural possibility of the plants of the natural resistance. There are some substances which can induce the resistance of the plants to pests and pathogens, and up to now they are sharing only a bit over 1% of total pesticides used, but this is the field for the research which could really support the plant protection. The inducers don't act on the pest or the pathogen, but they act on the plant and increase its natural defense possibility. So they can induce resistance to a broad spectrum of disease and pests at one time. They can also tackle so far uncontrolled disease, for example, viral disease. They avoid raising the resistance of pathogens because they act on the plant. They help decrease the usage of high-risk pesticides, and the doses which are used by these inducers is like 10 or even 20 times less than of the chemicals, traditional pesticides. So this is also the trend in the research. Another trend is to use the natural resistance in the some plants are genetically resistant to some diseases and pests. And there exist natural sources of resistance, and they are used by traditional breeders to develop new cultivars which could be planted in the fields commercially, and which could have natural resistance for some pests. The traditional breeding takes many years, really many, at least 10 years. There is still a lack of the fast testing methods for the new crossings which could help and which could speed up the breeding process. There was, everybody I think remember that there was in Europe, and there is in the world, the approach to use transgenesis, so to create genetically modified organisms by incorporation of the foreign DNA to the plant DNA. But this is not accepted in Europe, and we have not such a plans almost in the field. However, since a few years, the new doors for such a technologies are little opened, and for so-called gene editing, in particular, using the CRISPR-Cas system. But from one side, it is a trend. From another side, it is a challenge. A lot of research must be done, so the financial support of research is necessary. There are also problems with intellectual property, very widely discussed now, and the communication with the consumer must be correct since the beginning, actually, of creation of such a new varieties. And finally, we are going to the, I think, very important trend in the agriculture, so-called precision agriculture. And this precision agriculture is also connected to our HortiQD project, because this is what we are going to develop. Is very well, it will be the element of the precision agriculture. Based on the definition, precision agriculture is a plant production management system which uses new technologies like digital technologies, sensors, the decision support system. But the main core of this definition is that the agrotechnical treatments must be done at the right place, at the right time, and the right dose. Let's look on the evolution of agriculture. We have something like agriculture 1.0, 2.0, 3.0, 4.0, and 5.0. The 1.0, it was the beginning, like the handwork based on the tradition. In the 2.0, agriculture 2.0, we have some new machineries, chemistry, very strong chemization of the agriculture, of the environment, and the increasing scale of the production. And together with the trend of agriculture 3.0, the trend, the step of evolution, we started to work on the precision agriculture. So usage of GPS, variable rate, dose, and analysis of data. And precision agriculture is present in the next evolution steps up to agriculture 5.0, where autonomization, robotization will be the main part of the system. What is the trend? This is a really trend. The market is growing every year huge. The forecast is for the market of the smart machines for 2026. It's like the increase of 20% even. So this is really huge. In the case of plant protection, the very important part are smart sprayers with variable rate of application. The sprayers automatically adjust the spray rate to the, for example, the size of the specific trees. And this is made on the prescription maps, or this can be based on the sensors mounted in the front of the sprayers like LiDAR, ultrasonic sensor, or cameras. The data are transferred to the cloud and they're analyzed by AI algorithms, and information is coming back to the sprayer, just how much, where, and how much of the spray liquid should be applied. Also, very important aspects are like solenoid valves and float management, which based on this information sent from the sensor, they control application time, pressure of the spraying, and droplet size. GPS navigation system is also crucial, just to know where the particular amount of the liquid has to be applied, and also autonomous machines, so machines without humans, like tractors or drones. Another very important elements of the agriculture are different sensors, the global satellite navigation system, a smart machinery, which I mentioned before, remote and proximal sensing system based with usage of drones and satellites, multi and hyperspectral cameras, and DVI analysis, and so on. Of course, strong computers and fast softwares for the fast analysis of the data, and Internet of Things, which is connecting all these elements of the precision agriculture system, where the data are analyzed and sent to the farmer to make the proper decision. However, we have many already solutions in the area of precision agriculture, but in case of the pest and disease monitoring, we still do not have too much, and this is really challenging. Monitoring, what is monitoring? Monitoring is the foundation of integrated plant management. The decision about the treatment of the plants with pesticides must be based on the monitoring results. But how it looks in the practice? In the practice, during the vegetation season, farmer has to observe, monitor its, for example, orchard every week, and try to imagine what is the effort to monitor, for example, dozens of hectares of the apple orchard. This is really huge work, and that's why farmers are not often doing it extensively. And when it comes to the technological support for monitoring, there are only a few solutions available on the market. One solution of the automatic monitoring of the pest presence. There's a group of presents which are traditionally monitored by the traps, sticky traps, yellow traps, or the traps with the pheromone, which is attracting the insect to the sticky trap. But it is like the farmer has to work these traps every few days. However, nowadays. There is also available already on the market, and the farmers are really happy with this system. These kind of traps are connected with the camera, and camera is collecting images. The images are transferred to the system, image analysis system, and the farmer is getting the information that this pest is already in your orchard with such an amount. You should go to spray. It reduces the need of manually check traps in the orchard, and the system can automatically recognize pests and send the notification. And there is a very good aspect also that this is real-time pest detection. However, and we are going now finally to the HortiQD approach. In case of disease, there is no such a system which could help monitoring of the farms automatically. So in our project, our case study is apple. We are concentrating on the 3 diseases: fire blight, apple scab, and powdery mildew, and on the pests, mites and aphids. This is a group of pests which cannot be trapped on the sticky traps. And we are also working on the fruit quality estimation. The aim of the project is to develop an affordable, this is very important, affordable for the farmers and easy to use machine vision system for precision farming. We are going to develop a hyperspectral camera working in the area of infrared, mostly shortwave infrared, in the wavelength range 800 2000 nanometers. Special optical filter with high spectral and spatial resolution is going to be developed. The detector will be based on the quantum dots, but not the standard quantum dots. The new quantum dots will be developed in the frame of the project, and based on these new quantum dots, detector will be constructed. And also for the analysis of hyperspectral images, the new deep learning algorithms will be necessary. Here on the right side, you see such a scheme of the system. Based on this analysis, the pests and the disease will be identified. Everything will be correlated with the system data management and correlation system, and the information will be sent to the farmer via app. And all the system will be integrated with autonomous tractor. So it is like really the view of the future that farmer is not necessary to make a proper management, proper monitoring of the orchard. In this approach, we want to use the feature that during the process of disease development or the pest infestation, the reflectance of the light in different wavelengths is changing, and these changes are much better visible in the area of infrared than in the area of visible range of wavelengths. So we are calculating here the amount of reflected light and the range of wavelengths. This is important to develop the system for the proper identification and detection of the disease and pests. The project is really cutting edge. There's several problems which we are going to solve, and the first problem, which I mentioned already, limits the use of pesticides. So the solution is the precise decision support system we are going to develop. The necessity of regular apple orchard, which is time-consuming, work-consuming, and educated staff is necessary to do this, and just because this is so complicated, the farmers are not doing this, so then automated and autonomous system for orchard monitoring will be developed. The problem is that such a system don't exist, or they are not used because they are not available, or they are very expensive, like hyperspectral cameras are very expensive. So the aim is to produce the affordable machine vision system. Also, the problem of environment. To avoid electronic waste toxic to the environment, the sphere imaging detector array will be free of the toxic elements. To overcome the problem that the existing filters have many limitations, the new tunable Fabry-Perot interferometer will be developed with high spatial and spectral resolution. And because the huge amount of data will be collected during monitoring, the new AI algorithms will be for the fast analysis will be developed. Just a little information how is the approach and what we are going at InHort in the frame of this project. We are collecting of the data of the apple trees infected by the disease or infested by the pest. We are collecting data with spectrometers, with hyperspectral camera and with RGB camera, with different approaches, different settings, with different range, spectral range, and also after collection of RGB data, like you can see on this picture on the bottom of the slide, we are tagging RGB pictures according to established scales of the disease development, just to help the learn algorithms. Here's the example of such a picture. On the left side, we have RGB picture of the tree with fire blight, and on the right, how it looks in the SWIR camera. The SWIR images are proceeded afterwards. One of the elements is the classification of each pixel to the different categories. For example, healthy parts, healthy pictures means green pixels are corresponding to the healthy parts of the tree, and the red one to the diseased one. Just an example. And this is the data correlation system, which already exists. The farmer will be able to select his field and to have the information about what is happening in the orchard, in particular, even in on the particular tree. So, concluding, generally, plant health is in a time of the transition. 4 years already, but this transition is still very intensive, and I think in the few years we will have completely different picture of the plant production. We are shifting from reactive protection to predictive, data-driven plant health management. And our research in the frame of HortiQD project contributes to this transformation by the development of the automated orchard monitoring system. And the goal for the agriculture is clear: smarter decision, earlier interventions, and precise actions. And this solution will help to have the plant protection more sustainable. Mostly what is very important in the era of the pesticides usage reduction. And these new solutions will be built on the science, innovation, and intelligent monitoring system. So this is the webpage of our HortiQD project, and there is a QR if you are interested in some other details, what we are doing, how is the project constructed. You can find it on the website of our project. And thank you very much for your attention.
Thank you very much, Joanna, for your speech of this morning. So we are already collecting questions, but we will answer them at the end. At the moment, I would give word to Dr. Johan Bremer for the second speech of today. Johan Bremer is a project manager and senior researcher with more than 25 years experience in research and project management. And his research field is plant health economics with an emphasis on crop protection policy and phytosanitary risk assessment. So, Johan, whenever you want, the stage is yours.
Thank you for this kind introduction, also for the invitation. and also for a nice presentation from Johanna. I will also share some insights from a project in which we also collaborate with InHort regarding the social and economic aspects of the adoption of integrated pest management tools, such as this system which has been proposed in the previous presentation. Maybe good that we also have to start with an introduction of the objective of the support project. Support is a project under the Horizon project, and you can see also more information when you click on the link which you see on the the right side of this slide. Our project has started in 2023, so we are in the last year. And we have a number of objectives. So to build a support stakeholder ecosystem in order to co-create strategies and policies with all kinds of stakeholders, with the farmers in the center, but also advisors, supply chain partners, other service providers, policymakers. A part of our project has been dedicated to collect an overview of current and future IPM tools and to assess the impacts of those impacts on control efficacy, on the economic performance, and on the environment. The core of our project was to identify barriers and opportunities of the IPM adoption in the entire agri-food chain system, and also to analyze the role of farmer decision-making in that. And on the basis of these analysis, we propose policies and sector strategies for supporting the adoption and application of IPM tools and technologies, together with all relevant stakeholders. And as already mentioned, we are in the last year, so we have collected the data. We are in the middle of the process of analyzing the data and come up with results. And in this presentation later on, I will share some initial and draft results, which can be also helpful to understand what's important when you work on new tools and technologies and want to apply them. Our approach is that we have created a cycle analyzing the uptake of existing IPM measures, then look at what are the consequences of those IPM tools and technologies. So we have created a monitoring tool in which we can assess the environmental and economic impacts of different crop protection strategies. So when you apply more advanced and sustainable solutions, what are the environmental and economic costs and benefits? We also have a huge effort in analyzing the barriers and opportunities. So we have applied several instruments to collect the data. So I will present some analysis of in-depth interviews. But also we had an extensive survey with almost 4,800 responses across Europe. And also we have co-creation strategies to apply policy and private strategies. And in that case, we have applied the backcasting method. So sitting together with all kinds of stakeholders around certain crops in our case countries, what would we ideally be developing when we think about future and sustainable crop protection strategies? How should we come to that, and what kind of barriers should we overcome? We also apply a stakeholder ecosystem. So we have made use of 25 national crop clusters in 9 countries, in which we collected a lot of data and also have involved those stakeholders in give feedback on IPM strategies. Also have contributed to the collection of IPM tools and technologies. We also have community of practices in which we have more in-depth workshops, for example, for development of long-term future vision on crop protection strategies for certain crops in countries. And also we have a wider community of in which we have combined the 9 community of practices into national crop clusters and brought together these participants across the national crop clusters and in 25 national crop clusters into a stakeholder community, and that meets a few times a year online and once a year during a general assembly in person. So a few weeks ago, we had our meeting in Rome and met representatives of the network of practice. It's also good to know that we have a number of cases and countries. So we have 10 countries across Europe and 8 different crops. And so for each country, we have 2 or 3 crops selected representative for that specific country, in which we have more in-depth results. And one of those, for each country, one of those crops has been put in the center of the national, the community of practice and national crop cluster. Then I want to share some initial results, which have been presented a few weeks ago, and I have to emphasize, so these are draft results, so we are in the middle of the analysis process, so more results are going, we expect them to be present in the course of this year, and which always also be addressed in a policy synthesis and also policy briefs. So, but I think I've selected some of those results which can be relevant of your projects. What we did is that we have collected data via a survey among participants in the Farm Accountancy Data Network, which is a data network of farms in which we collect a lot of economic data, which is an obligation for all member states in the European Union. And we can make use of this database with extensive data to collect additional data, and that's what we did by applying an additional survey focused on the adoption process of IPM tools and technologies. And we have applied it in 4 countries, in Italy, the Netherlands, Poland, and Denmark. And what we see also is in Italy, there's quite a relatively low adoption of IPM measures. In the Netherlands, it's higher, and also mainstreamed. Let me see, high adoption, especially for arable farms. In Denmark, we see a balanced adoption level, higher than Italy and Denmark, but lower than in Poland than the Netherlands. And also in Denmark, it's a lower adoption rate, and compared to the Netherlands and Poland, but higher than in Italy. And also good to know that the case crops in both Poland and Italy were apples. And when you look into more details regarding what type of measures did they implement, we have made a long list and asked to what extent they have been adopted by those participants in the accounting data networks. So you can see the number of participants in Italy, Netherlands, Poland, and Denmark. So more than 300 in Italy and around 100 in the Netherlands, Poland, and Denmark. And you can see a number of those elements, for example, which have been applied. So what we can see, I think, when you have the lower use of prediction and warning systems, it's quite low in Italy, it's high in the Netherlands, it's on average in Poland and Denmark. What we also have conducted is a number of in-depth interviews with farmers and advisors in those 9 countries. And these have been extensively analyzed, so give a lot of qualitative background information. What are the reasons for adoption of IPM tools and technologies? And what we can see is when we look at the main categories of barriers, and also we have this made a distinction between the farmers and advisors. So we have partly interviewed farmers and partly advisors, and it's also good to compare these. And what we see is that the main categories of barriers for adoption are environmental and biological barriers by farmers, economic barriers, also very important because of the costs, but also regulatory and policy barriers and lack of resources. And that can be financial resources or technological, informational, time resources. And when we compare it to the advisors, we see some slight differences. Advisors, they pay the most attention to advisory knowledge gaps as a main barrier, but also like the farmers, they have they mention economic but also market constraints, so that markets have some barriers, maybe for example that you cannot deliver the same quality when you apply IPM tools and technologies. And they also mention the third item, the regulatory and policy barriers. We also have looked at the perceived impacts of the IPM tools and technologies, and the farmers, the most mentioned were the effectiveness of pest control limitations. So that the efficacy of alternative measures is less than the conventional pesticides. And also in second place, shortly following the first one, is the economic and market challenges. So negative economic by higher cost, maybe also reduced yield. But also practical barriers are mentioned as a negative impact, so more labor intensive, for example. Advisors have also mentioned economic and resource related challenges in the second place, and technical and practical implementation, and knowledge, awareness and human factors on the first and third phase. So I think it's also close to their role to advise about the adoption, and they can also see the constraints they perceive. When we focus on opportunities mentioned, it's also good to see that in the first place mentioned by farmers, they see also economic and market related opportunities as a factor that's important for the uptake of IPM. Agronomic and technological solutions, so expecting new techniques on the market, and also the sustainability and environmental benefits are mentioned most. And also we see quite comparable factors mentioned by the advisors. They mention knowledge, training and advisory support as a main opportunity. So investing in training, educating farmers can help them to apply IPM. And in the second place, they also mention economic and market related opportunities. So it's more or less there is consistency between what farmers and advisors mentioned. Also positive impacts, not surprisingly, I think they mention both environmental and ecological benefits as a main category, but also improved crop health and yield stability and economic viability. And also efficient use, impact, input and cost reduction mentioned by advisors, and crop health and productivity. When we focus on critical success factors and main categories for uptake, farmers mention supported information and also financial and economic factors, and help with the adoption strategy and guidance. Advisors also mention practical implementation, economic consideration, and knowledge sharing and collaboration as main critical success factors for application of IPM tools and technologies. So when we focus on conclusions, most mentioned negative aspects are from operational and technical aspects, effectiveness and availability of alternatives, and also some practical implications. How does it work? Tools and technologies, and in the third place, the economic aspects and knowledge. When we focus on the positive impacts, they also mention the economic benefits. So that's, I think, a very good to have that factor also on board on the positive side. Agronomic and technological developments, and also knowledge development. What we see is also there is a large overlap between what farmers perceive, both positive and negative impact. Although we see some slight differences, so advisors have put more emphasis on training and education and external factors, whereas farmers have more emphasis on the factors which are close to their farms. And what also is important to see that there is no country or crop specific pattern to be to detect in this analysis. So it seems that it's quite universal between crops and countries. So I think it's also important to have this information on board when you develop a new technology such as the advanced monitoring system, that you have to think about how to implement that and provide a fruitful receipt. It means that you need to pay attention to the I think the knowledge, because it's a knowledge intensive technique that needs to be developed That means that you also need to involve your advisors in practical implementation and also look what are the economic consequences of such an application. I can imagine that it has a lot of environmental benefits, but maybe it can be also a costly measure. In that case, it could be good to think about options to apply such a system by multiple farmers itself and to share the costs to reduce the cost per farm. So this is in short my presentation. So I'm also open for questions from your side. Thank you.
Okay, thank you very much, Johan. So first of all, we have a suggestion from Wilhelmina, and he told us that she would suggest that that we focus more on the relationship between plants and soil life. So I don't know if you want to answer this consideration first of all, or we can proceed with the question, Johan.
It's a question to me?
No, it's not a question, it's just a consideration. Yes. Okay, concerning the question, I think this question is more for Joanna, but Johan, if you feel to answer, you can. Shoshana Sakare asked us, do you think intercropping could help with plant protection? For example, with medicinal and aromatic plants, because they have active compounds that are antimicrobial, antifungal, and so on.
So I can try to answer it first. It can help because this is one of the elements of agroecology, which I mentioned during my speech. The agroecology is also the trend. So the application of the intercropping, for example, yes, and many others pro-ecological activities. But I'm wondering also how and such a system, they are nicely work in the small farms, for example, small organic farms. But if we take into consideration that from the social point of view, I think, Johan, you can perhaps say something more, that the new generation of, so the children of the farmers don't want to be farmers anymore. And we still will need something to eat. So it seems that the development of the agriculture will rather go to the big farms, like more like not like a family small farms where it is more easy to manage it, but the really hundreds of hectares, for example, of the orchards. So in my opinion, in such a system, just intercropping will not help us too much.
Okay, thank you very much, Joanna. We have another question from Sharmita Sharma. Hi, I'm a graduate master's student in the BOOST program, the Biocontrol Solutions for Plant Health from Université Côte d'Azur. I had a question about the monitoring tools you mentioned, especially hyperspectral imaging. Is this technology already ready for the market so that farmers can use it directly in their fields? And how can farmers be confident about the reliability of these tools? Also, could you explain the importance of using infrared waves to monitor plant health?
Just shortly, we are still running the project, so the system is not ready. And we are not finishing it is not the plan to finish with commercialization. We are going to finish, as far as I remember, on TRL6. So this is still on I think the level of the prototype. I'm not sure, but it is. So the system is not available, and it will be not very soon available. Why infrared? I mentioned it, but maybe just shortly, because generally the detectors are based on the detection of the reflected light. And in the infrared area of the wavelength, the reflection is much higher than in the visible rate of range of the wavelength. So this is the approach that just in the infrared and mostly in the shortwave infrared range of wavelengths, the information which could be collected from the plant is much much higher, much deeper, and this information could bring this reflected light could bring more information about the health status of the plant. So just shortly, I'm not sure if I answered all the sub questions of the question.
Yes, I think yes. I don't know if Johan, you want to add something?
No, thanks.
Okay. So we will wait just a couple of minutes in search of other question, just to check if someone else maybe is typing or you know needs more time. In the meantime, I will share in the chat the feedback form for this this webinar. So if you want to tell us something about the today's webinar, you can share your thoughts here. It's completely anonymous, as I said. So here it is. It should appear in the chat. Yes. So thank you very much to Joanna and to Jan for your speeches, and thanks also to all the today's participants. I'm just wanting you to follow our social media and website, because this webinar has been recorded, and we will be sharing it on the social media and on the YouTube channel of HortiQD project. So if you want to rewatch it, you will be able to do so. And I think that's all. Just keep following us, because there are more events like this one ahead. So that's all for today. Thank you very much to everyone.
Thank you.
Thank you.
Thank you.
Bye.
Thank you.